Hello, everybody. Thank you for joining my presentation. So today we are going to talk about some concepts we call integration as code, more specifically how to integrate application using those concepts. My name is Antoine Cotten. I'm a senior software developer at a company called TriggerMesh. And before we dive into the topic, let me give you a lightning introduction about TriggerMesh so that you can understand how integration as code actually relates to what we do. So our team at TriggerMesh is comprised of cloud developers and operators who formerly were at companies like VMware, SAP, Chef, Elastic, and more. Our leaders have authored popular books such as the O'Reilly Kubernetes Cookbook and projects like Kubeless, which you may have heard of maybe. We have some solid backing from Index Ventures, Crane, Cisco Investment, which actually backed companies like MySQL, Elastic, Confluent, and Kong, among others. And also very recently, we took pride in having parts of our product integrated into the cloud-native runtimes for VMware Tanzu, which went GA last month in July. So broadly speaking, what is TriggerMesh? TriggerMesh is a cloud-native integration platform, which is based on Kubernetes and powered by Knative. So what does it mean concretely, and what problems are we actually trying to solve? At TriggerMesh, we believe that developers will build event-driven applications that integrate services from multiple SaaS cloud providers, on-premises applications, and I'm sure you're well aware of the multitude of software solutions that a typical business has to deal with on a daily basis. Many of the examples in this particular slide may even be especially relevant to some of you in the audience. So on the right-hand side, you see a variety of SaaS systems which companies, maybe including yours, are embracing to handle increasingly specialized tasks. We think about cloud, about source control, about data visualization, search, analysis, CRM, communication, etc., etc. In the middle, you will have recognized the public clouds, where people are increasingly moving workloads and services while at the same time accelerating their use of data streaming with solutions such as Kafka. And on the left side, another category that we should not forget, which we call the legacy applications. So for example, databases, ERPs, etc., which are another variety of workloads that usually run on premises. And more often than not, these applications are even connected with enterprise service buses, which are yet another category of software which needs to be integrated. So what our customers tell us is that it is very complicated to integrate across this mix of solutions. Existing integration approaches are slow to implement. Anything which is multi-cloud usually requires weeks to months and lots of consultants. And neither are integration self-service, right? They're often very brittle and difficult to maintain. So if you want to share with us how your company, for example, currently approaches cross-service integration across SaaS, across clouds, on-premises, feel free to answer the poll that we will be sharing with you right now in the chat. So here at TriggerMesh, we set to answer one critical question. And this question is, how can modern DevOps teams more efficiently integrate this growing mix? Right, and our answer to that is a single platform where we take all these silos and we tie all your cloud and legacy systems together. So the TriggerMesh integration platform is built on Kubernetes and Knative. It uses an industry standard called Blob Event to connect virtually any application with virtually any other, regardless of their infrastructure. That is the promise of TriggerMesh. All right, so now you're familiar with TriggerMesh. Let's talk a little bit about a project called Knative. The reason why we talk about it today is because Knative is the core of the TriggerMesh platform. So by understanding the basic principles of Knative, you will already know a lot about what powers our integration as code. So Canadive is an open source project that was started by Google. The copyright is still owned by Google, actually, but it receives a lot of contribution from other major industry players such as VMware or Red Hat. Even before that, they received contribution from Pivotal, IBM. All these companies are nowadays together, but the contributions are very actively pushed to the project nowadays, and it's not only by Google. And even TriggerMesh itself is a top 5 contributor to the Knative project. So to put it simply, Knative is a Kubernetes-based platform to deploy and manage modern serverless workloads. It has two main components. One of them is serving, the other one is eventing. So serving is here for running compute type of workloads. So we talk about any containerized application, and it focuses on autoscaling and the routing of HTTP traffic. On the other hand, eventing focuses more on event-driven architecture and asynchronous communication. So the reason why I say that these two components are meant to work together, it's because it is perfectly possible in Knative to run applications such as microservices or function using Knative serving, and also allow the application to communicate over data channels which are provided by Knative eventing. So what we did at TriggerMesh, we built our product on top of these two primitives, on top of this open source project. Right. So today we are going to focus much more on Knative eventing than serving. Serving is going to be used, of course, in the demos and so on, but really the gist of the integration as code is within Knative eventing. And the goal of Knative eventing can be summed up in a single sentence: to connect event producers to event consumers in a loosely coupled fashion on top of Kubernetes. So because it is a layer on top of Kubernetes, Knative allows us to do all of this via a declarative API, which slowly takes us already to the main topic of the presentation, which, remember, is integration as code. So we are now transitioning into, after this introduction, into a more technical part, which is by far my personal favorite. The demos that I will do in front of you will assume some familiarity with the Kubernetes API, but don't be afraid if you don't consider yourself an expert, right? Stay with me. Some basic understanding is more than enough to be able to follow along. So when we talk about the life of an event in TriggerMesh and in Knative more particularly, we think about different challenges. So the first of these challenges is that we want to support routing events from an external system into one or more destinations. This destination can be, like I said, a Knative service, so any kind of container workload. It can also be a function. And this is the core of building a reactive event-driven system, right? You want to deliver event notification from systems that produce them to components that consume them. So the solution to this in Knative, and by definition in TriggerMesh, is to use a standard delivery protocol for passing the event notification from one component to the next. So any component within our system will use the same protocol, and this protocol is cloud events over HTTP. So cloud events, think about it as a specification to transfer data in a well-specified format. So cloud event is nothing more than an envelope that contains metadata and some data, and which is transported, in our case, over HTTP, but it could be over a different protocol as well. So now that we have the protocol defined, we want to support delivering events from many potentially external systems. And there are already many third-party systems which already exist, and they allow you to deliver event notification in some kind of way, right? For example, picture a GitHub repository. You can consume events already from GitHub via webhooks. Or you could be tailing logs from a system, any kind of system. You could consume messages from pops-up notifications over various protocols, right? But configuring and receiving this event notification is custom for each system. So the solution that brings Canadive for that is that we build a source adapter for each system to translate the subscription request to an event delivery. So typically this adapter will be nothing more than a Kubernetes object, a custom resource, which is backed by a container. Now, we also want to multiplex this event delivery from a single source adapter and allow potentially multiple subscribers to consume that data. So event notifications from external systems may face several types of inconvenient limits. You can think of number of notifications, the throughput, the durability may also be limited. So for that, Knative has a construct called a broker. So instead of forcing the source adapters I was talking about to become much more complex, to add much more logic to every adapter, Canadive can deliver events to a broker. So think about a broker as a content-based message router, which allows messages to be stored and to be delivered as a single central piece in your messaging system. Okay, but this is not enough. We have a last actual challenge, is that we want to support delivering these events from a broker to different destinations. And not every destination may be interested in every particular event, right? And developers also particularly don't need to keep track of specific named channels or pipes. So the solution, the broker acts as a central hub, like I said, for events in a durable way, and it is already allowed to do some fan out of the store events to multiple destinations. But what we add on top of that is something called a trigger, and the trigger allows binding subscribers to the brokers using a type of subscription which allows you to do some filtering on those events. So you can technically consume a specific list or a specific type of event from a broker, even if that broker contains much more events than what you're interested in. And this relies purely on cloud event attributes. So remember, I mentioned before, the cloud event specification is simply an envelope which has some metadata and some data. Right. So this last slide, I'm not going to spend much time on it, but when you think about event-driven system, it's also very important to think about delivery guarantees, right? And this is actually the main reason potentially why we do asynchronous communication on event-driven architectures, is that we want to be resilient to failures. We want to ensure that an event is going to be delivered. And Knative uses, so it supports at least once delivery semantics for event notification, which guarantees that the delivery success is acknowledged by the receiver, and the sender must also replay on failures. Duplicates can happen in this case, but the consumer must ensure that operations are idempotent. So this is the global delivery guarantee of Knative eventing in general. It also supports dead letter queues. So if an event cannot be delivered at all, you still have the possibility to deliver this event to a dead letter queue. Even if the consumer is not able to receive these events, you will still have them stored somewhere and you will be able to consume them at a later time. Okay, so now you know about the core of TriggerMesh. You know potentially how an event-driven system works in TriggerMesh. We're going to talk more about how you use that now, how you declare a system in an event-driven system in TriggerMesh, right? So the TriggerMesh application flows are bundled into what we call bridges. So bridges are a set of Kubernetes objects which are deployed and tracked as a unit. The fact that we use a Kubernetes foundation gives us a declarative mindset to these bridges. So not only we have APIs for declaring event sources and event destinations, like we saw in the previous diagram, but we also have API for controlling the data flow. So we allow you to declaratively do some filtering on messages, splitting on the data contained in these messages. We allow you to have functions which manipulate the data of these messages and perform some transformation on them. So the bridges allow you to reason about an event-driven system, an entire event-driven system, as a single API object, and to provide information about the status of their components through a single API call. So if you are already familiar with Kubernetes, you know that a single API object has a single status, which allows to consumers to know if the object is actually healthy or not. So this is what a bridge is. It is a very interesting construct as well, because by using bridges, you can deploy the systems on Kubernetes using the deployment tool of your choice, right? So it's nothing more than a custom resource. You can deploy it using Helm, you can deploy it using Customize, using the Carvel tooling, and so on and so forth. All right. So I promised you some demos. Here's the first demo of this presentation. So this will be, I would say, a very simple integration between cloud storage solution. So Amazon S3 for AWS, Azure Blob Storage inside Microsoft Azure, and Slack on the other side. So I really like this demo because to demo this integration, because it is visual and the outcomes are simple to understand, and yet it involves several of the constructs which, in my opinion, make Canadive and the TriggerMesh platform very powerful. So let me switch my screens now. Okay. So you should be seeing my terminal right now, and I will open a whiteboard. I'm going to draw what we're going to show you today. So we said we would have two event sources here, which are cloud services. One of them is Amazon S3. The other one is Azure Cloud Storage, Blob Storage. And on the other hand, we are going to send all the events emitted by the services to a Slack channel. So S3 is going to be one event source, which I'm going to put here on this diagram. And we will have Azure Blob Storage on the other side. All right, so this is the S3 source. This will be the Azure source. And at the other end of the system, we will have a Slack channel. All right. So like I said, all the system is going to be described declaratively. So it means we will reason about everything you see on this diagram as single Kubernetes object. So let's get to it without waiting. We will create a new bridge here, which I have already populated for you. So a Kubernetes object always has an API version and a kind, which defines what this object is. And by having this API version and kind, we know what specification is going to take. So a TriggerMesh bridge simply takes a list of different Kubernetes objects. It groups everything under a single object with a name. So this is called storage demo. And you can already see on my screen the first event source here. So we have one source for Amazon S3. To declare this source, you simply have to provide, like any Kubernetes object, another API version and kind. So you can recognize an API here, which is provided by TriggerMesh with a kind AWS S3. And then if you scroll down to the specification, you see maybe something familiar if you use AWS, which is an ARN, which uniquely identifies the S3 bucket we want to target. It has event types. So the event types are the type of notification we want to subscribe to. In this case, every time an object is going to be created or deleted in our S3 bucket, we are going to receive that event inside our Canadive system. And you also see other fields like credentials. And I already want to point out that if you haven't used Kubernetes before, you will see a format which you might not be familiar with. You will see a value from secret, which has reference to two different fields, a name and a key. I especially want to point out that these fields are not always what you want to expect from a simple system, right? You expect an integration to maybe allow you to describe only what actually qualifies the S3 bucket in this case. But on top of that, you see fields which are very technical, such as how to format a credential, how to reference credential to what. And you see another very technical element here, which is an event sync, which in this case is a destination for events. So a destination for events is going to be here another Kubernetes object, also declaratively written in a configuration called a bridge. And this has, like everything else, an API version, a kind, which this time is a Slack target. So what you have to remember from that is that our S3 source here is defined to consume events from a S3 bucket identified by an ARN. We consume only specific type of event types, and we send all these events to an event sync, which is the Slack target. Okay, so to speed up the demo a little bit, I actually already created the S3 bucket. So you can recognize here this TriggerMesh demo is what we are going to subscribe to. All right. So we have the exact same thing. I'm not going to spend so much time describing the event source for Azure Blob Storage, but this is the exact same principle. We declaratively describe what our event source is going to be. And this is, in this case, not a bucket, but a storage account. We want to send events over something called an event hub and subscribe also to event types. And again, you see very technical fields which allow you to define the authentication method. So in this case, something called a service principal, and to send events to a sink. Okay, and this blob storage container, we are going to create it right here in something called a storage account. I'm going to call it logo because I will use it to upload some logos during the demo. Okay, so we have our event source. If I get back to the whiteboard, we have our two event source, S3, Azure Blob Storage. We want to send events to our target. And this target in the TriggerMesh bridge is also another Kubernetes object. This time much simpler. It only has a token to authenticate against the Slack API. But you will notice something. When I was talking about Knative eventing, I was describing much more than just sources sending events to target directly. In the middle of that, there was a broker which allowed us to do some actual asynchronous communications, right? So we need also to do in our description of the bridge, we need to include a broker. Okay, so this broker will receive events from the event sources instead of sending directly to the destination, to the subscriber. The sources now don't have to know about what the destination of the events will be, what the consumers will be. The broker will be responsible for storing all these messages, and the subscribers will come and simply fetch those messages. So we also add a broker to our description. The broker is not provided by TriggerMesh, but it is a core Knative object of kind broker. Its specification is very simple. A broker simply has a name. It can be backed by different systems such as Kafka. It can be in memory. It can be backed also by RabbitMQ, for example. But in this case, we are simply going to use the default provided by Knative. So we don't specify anything else. So it is very, very easy to specify a broker in this description. And since we did that, I'm going to have to change the references to where the events are going to be sent, right? We had in our description here a sink, which was referencing the Slack target directly. But we don't want to do that. We want, of course, to send events to our broker. So we have to update this reference. And the reason why I do it explicitly in front of you here is, again, to show you that even if we have a declarative API, there's still some consideration and there's still some very technical consideration to think of when you describe such system, right? So the declarative philosophy gives you reconciliation of all this in the backend, gives you the guarantee that this is going to be kept up to date all the time for you. But on the other hand, you have to know the system very well to be able to enable these communications, right? And you will see why I want to really put emphasis on that later. So we have our event broker. Remember when I was speaking about Canadive system, there's still another last element that you need in your system to actually send those events in a filtered manner to Slack. And those are called the triggers. So we have two triggers. I'm just going to call them T. You would think that we would send them directly to Slack, but there is a problem here. If we do this, the Slack target is simply not going to be able to consume messages, or is going to print potentially a very complex payload, because the messages sent from S3 or Azure Blob Storage are very large JSON payloads. But when you communicate in a Slack channel, you usually want things to be short and understandable by humans, right? So what we will do here, we will perform a message transformation using a function. So we will interpolate two elements here, which are functions. So there will be a function that transforms the events for S3, from S3 to Slack. And there will be a second function which understands the format of Azure and is also going to format them in a certain manner so that they are easier to read in Slack. So we can also do that in a declarative manner, just like everything else I showed you. So how we do this? We create our triggers. The triggers are targeting a specific broker. So storage demo is the name of the broker we have in our system here. Right there. The triggers reference this broker by name, and they will also filter events by type. So the type of this events is very source specific. In this case, the source of an event coming from S3 bucket will be an ARN, so an AWS ARN, and it will have a subscriber, which will be, well, not a target anymore, but a function. So I will show you the definition of this function. First, let's comment the code. And we have the exact same thing for Azure. So we want to consume Azure events. We want here, consume Azure events by type, send them to a function. And the function is going to perform transformation on the data, which we will show you. Okay, so the reference is now the function, not the target. And finally, the transformations are simple. Here, Python function. So this is an API which is as well provided by TriggerMesh, not by Canadive. Function object can allow you to manipulate incoming data using an interpreted language. So we currently support Python, which is my favorite, but also in Node.js or Ruby. So you could write it in the language of your choice. But I wanted to show you here a very simple transformation when I was talking about Slack integration, and why I particularly like it is that Slack is mostly text, right? You don't have formatted data in Slack. So the only thing you have to provide to a Slack message to have it formatted would be the identifier of a channel, and the text will simply be here. You know, we want to extract specific fields from the data. So I will show you the data, but just know that we want to show, for example, the type of event which is coming in. So we consume a specific field from this JSON data. We want to show the bucket where the event is coming from. So likewise, we just reference a field in this data. And by simply doing that, also for the object, we have already created a new message, which is altered from the source message coming directly from S3 or Blob Storage. And we have converted it to a format which Slack can consume. So this is also another of my favorite thing, right? Being able to declare a function in the system and have it transform the message in the format that I want, right? Using a language which I'm familiar with. If you look at the blob storage transformation, it is very, very similar. It also takes the reference to the same channel and gives the type of event which is coming from Azure, the storage account, the object name, and so on. Okay. So I'm now going to create this bridge in front of you. It's going to be a single object created in my Kubernetes cluster. You will see all the elements that it contains being created, and the status of all the systems, so the entire system, will be reported when it is ready. So we expect that to be extremely fast. Just for monitoring purposes, I also have something I call a wiretap, which is a web service here called Sockeye, which is not very interesting here for the demo, for the actual system, but it's going to show us in real time the events which are going through the bridge. So let's go for it. I hope I didn't forget anything. The Slack, if we have references to our functions here and there. So Kubernetes create mybridge.yaml. Oh, so I have a bridge called storage demo, which has been created. We can inspect declaratively again the status of this object. So it's called storage demo. So after a few seconds, you can see that the status will change, and we are expecting it to eventually become ready. Okay, so there are updates happening. It means components are coming up, not at the same time, but you can see updates, and eventually our bridge is going to become ready. So ready true here. It means everything is ready to serve. It took literally 39 seconds. We are now consuming events from our S3 bucket and from our Azure Blob storage. How we can see that? By simply going in the properties of the S3 bucket, scrolling down to event notification, and you will see that a few seconds ago, a new event notification going over SQS has been created for all created objects and all deleted objects. Okay, so Sockeye is this web service here. It's a very simple web interface that shows events coming in. So let's create an event. Let's generate one payload, one message by uploading a file. So I told you I want to play with logos, so I'm going to create for this demo the TriggerMesh logo. Upload it to my S3 bucket and click go. So as soon as this is going to be uploaded, you will see the payload I was talking about. This is a very large JSON, right? But there is very interesting information in this JSON, which is what actually happened. So here an object was put in my bucket. There is the name of the file which was created. Here, TriggerMesh square white.png. Also in the subject here in the metadata of the event. So what you see here is the cloud event. The cloud event is simply a list of attributes, key values, and the payload as data. So you can think about it as a HTTP request, for example. In an HTTP request, you also encapsulate metadata as HTTP headers, and you have your actual data in the body of the request, right? But so cloud events is very similar, but for events. Okay, so if the message went through my transformation here correctly, we should have received it in Slack channel. And indeed, 1 minute ago, we received an event from S3 saying that I have an object which was put in a bucket called TriggerMesh demo, and this object is the TriggerMesh square white logo. Okay, so we are going to do the same in Azure to show that everything is wired properly, that the broker is connected. The Slack channel is subscribing to events from Azure via a trigger, and that the message is transformed correctly using our declared function. So we have our container here. We want to upload a logo to it. I'm going to upload the Canadive logo this time. And Sockeye has shown a new event that has come in. This time it is a blob, so coming from Azure. The source of this is the storage account called TriggerMesh demo as well. The subject here is the knlogo.png. Let's go to our Slack channel, and we indeed have received another message from the TriggerMesh Slack integration, which describes what was done. So put another blob from a storage account called TriggerMesh demo with an object called knlogo, right? So all this happened really fast. It took 39 seconds to create, and I can already source events from multiple systems, transform them in the format I expect, all this declaratively, and being reconciled in real time in my cluster. Okay, so because it is a single object, it means I can also take down this bridge as a single deletion. And suddenly my integration is gone. I don't have any more subscription to my TriggerMesh S3 bucket. Right, event notifications are gone here, and the same happened in Azure. Okay, so I'm going to stop sharing my screen and get back to the presentation shortly. Okay, so you should be seeing my slides in a second. So, like I said, this integration was really, really quick, right? But it wasn't extremely complex, but it was not trivial either, right? We did some transformation, we did some, sourcing of different event types to different destinations, and all this declared as a single Kubernetes object. What I'm curious to know now is how long it takes your company, for example, to get a new cross-service integration on average. And if you feel like responding to this or sharing, you can do it again in the polls that should have been shared or will be shared in a second. Okay. So the conclusion to that is that, yes, you can use a declarative API, and it's extremely convenient, but even declaratively building a system like this requires some intrinsic knowledge of the Kubernetes API, right? Secret reference, what is a sink, what is an API version, kind, how to wire everything together, what is the spec of each object, and you rapidly end up with walls of YAMLs. By allowing powerful but complex new ways of composing the systems, using loosely coupled API objects, we add another layer of complexity to a software stack which may already have its fair share of moving parts. And this is not exactly what we want, right? When we talk about integration as code, we think about simplicity, we think about abstracting away the technical details. So our solution at TriggerMesh to this problem is to go a layer or a little bit further with that concept of integration as code and create a language which allows expressing event-driven architectures more naturally using a custom description language. So this is this is meant as a human-readable language, unlike YAML, which is specifically designed for describing complex systems like the one I was showing you, where components communicate asynchronously on top of Kubernetes. And we also still want to preserve the declarative aspect because we still really like it. So what we did, we based this language on the HCL syntax from HashiCorp. You may already be familiar with this if you use HashiCorp products such as Terraform or Packer. So this language can be used. It has a toolkit which allows you to create your own language, even if most people associate that with Terraform, of course. It is not the only way to use HCL. And the TriggerMesh integration language is not an alternative syntax for writing verbatim Kubernetes objects either. It is rather a collection of abstractions which are inspired by the enterprise integration patterns. So these patterns were originally created and described by Gregor Hoppe and Bobby Wolf, They describe different styles of software integration which software architects can refer to in order to design their systems. To quote them actually on these patterns, they say it is a collection of integration patterns to establish a technology-independent vocabulary and a visual notation to design and document integration solutions. So the one we are interested in at TriggerMesh in particular focus on asynchronous messaging architectures, also called event-driven architectures. At the end of the day, what we want to do is to let you compose your own messaging system using the power of those messaging patterns. And we do this either by composing together multiple Canadive objects. So you have seen in the previous demo, we have used brokers and triggers. We will show you now some constructs which are bringing that together in a single construct, which is much easier to consume and write. And we also, on some occasion, create our own messaging building blocks. So like filters or data transformer, similar to the function that you've seen before. And directly inspired by the patterns I just described, we have segmented the messaging components into 5 categories. So instead of having just a list of Kubernetes objects, you now have categories which are event sources, event targets or destinations, message routers, data channel, and data transformer. What we think is that in this 5 category, you can put any of the elements you were seeing in the demo before and represent any of the elements of the messaging system. So I'm now going to shortly draw a parallel between infrastructure as code and integration as code. Because why is it interesting? Well, it's because infrastructure as code exists so that developers and operators can safely and reliably deploy changes to their infrastructure, and how using familiar software development flows. And typically infrastructure as code, such as Terraform or Pulumi, they work by resolving dependencies between hardware components and cloud services. And the goal of that is to provision the infrastructure which backs the modern software. So beyond the declarative aspect, one of the reasons why we refer to TriggerMesh APIs as integration as code is because we reuse some of these concepts ourselves. So for example, in the TriggerMesh integration language, by declaring connection between our messaging components, exactly like one would declare connection between cloud services in infrastructure as code, we can reason about this entire messaging system that you saw before as a directed graph. And not only this graph theory allows us to optimize the rollout of the Kubernetes objects underneath by determining the relationship between them, but it also allows us to understand the data flow within a system ahead of the actual deployment. And we can report to users potential errors by static analysis even before the system is even deployed. And last but not least, it makes it very easy to represent this data flow graphically. So although we don't support it right now, we do support the visualization, but we could also potentially offer a visual way for users to not only visualize, but also design them in the future. And this is something we are very interested in by exploring integration as code. All right. So the next demo, it's going to be much quicker because we are going to show the exact same thing as I showed before. The only difference is that now the same bridge is going to be written in the TriggerMesh integration language. And I'm going to point out a few things which have changed and which have been made much easier by using this language. So give me a second to switch screens. Okay, you should be back with me with my terminal right now. So again, one last time, I'm going to show you the system we're trying to resolve here. Remember, we used to be declaring every single object one by one, right? The broker was one object. Every trigger was one object. This was already 3 objects to declare simply the wiring of the objects. The connections were explicitly defined as API version and kind, which means you cannot use the system if you're not familiar with the Kubernetes API. You have to know the type, the API version, the spec of every single object. With the TriggerMesh integration language, the same bridge here so I have a little representation, is expressed much easier. So of course, the specification that we had before for the ARN of the S3 bucket, for example, and the event types is not going away. This has to be defined every time, right? But you can already notice a big difference here, which is, for example, the way we reference credentials. So we reference credentials not by specific fields anymore, but simply by secret name. So we rely a lot on the notion of secret categories or secret classes, which means a source for AWS S3 is always going to use a secret type, a secret of type AWS, which contains an access key, a secret access key. Likewise, if I scroll here to my Azure source, we are always going to use a secret which has a certain type, which is relevant only for Azure, right? And this is a tenant ID, a client secret. We don't need to express this explicitly every time. If we know what the shape of the secret is going to be, we can just provision them ahead of time. For example, in the TriggerMesh platform, here, you can see our three secret, one for Slack, one for Blob Storage, one for S3, and you can simply reference them. The other thing which has been improved a lot here is the reference to different objects. We are not anymore having something like a sink which references a certain API version and kind. This is all gone. Every object in this file can be cross-referenced by type and by name. So if I want to send events here from my source to a router of name dispatch, I simply have to reference this by its type dot its name, and it doesn't matter what API version it currently have in the cluster, it will be resolved for you. So the next improvement here, beyond the event targets, which are also a bit shorter, right? You don't have API version and kinds are gone here as well, is that we can mash together all the event wiring with the router, the broker, and the triggers into a single object. So the single object, we decided to call it a content-based router. So router is the category, remember? We have categories for source, for targets, for routers, channel, and transformers. This is a router of type content-based, which allows you to distribute your events wherever they come from based on their attributes, or based on a filter expression, which I'm not showing here, but you will see it in my conclusion. And we don't have multiple objects anymore, but we just have a list of routes. And if I now want to, let's say, distribute this event to a new destination, I don't have to create a new trigger. I don't have to reference a broker anymore. I simply have to add a new element of type route here with, let's say, a different attribute. Give it an example and give it a destination, and all the wiring is going to happen for you, right? You don't have to know how to do that. You don't have to know Knative anymore. And last but not least, you don't have to put your functions in line in a YAML file and have to think about the indentation and so on anymore. You can reference a file which is simply on your file system and have it simply using, I don't know, the ID of your choice, write your code, for example, my Python function, have all my syntax highlighting managed for myself, put it in a different file, reference it from the bridge, or the bridge now expressed in the TriggerMesh integration language, and this is going to be resolved for us. Okay, so I'm going to go very quickly generate this bridge now. You will see that a lot of the things you saw before are familiar. We have our sources. We have secret references managed for us. We have the wiring managed for us, and so on and so forth, right? And we will simply be able to create this application by passing it to the tool of our choice. So like I said, we can use Helm, you can use Customize. I really love the Cap, the Carvel tooling, including the tool called Cap. So I like to deploy my bridge using Cap. I can do it by simply passing it the output of the till generate command, which generated all the subjects for me, and create them in my cluster. And by doing this, you see that the exact same thing that happened with the bridge before happens here. I have my different sources. my functions, my targets, brokers, and triggers have been resolved for me, and I can simply deploy them. All right. So I'm not going to demo that the events are still going through the system because it's the exact same thing. But you can see that the authoring of the bridge was much easier, and also its creation was much more flexible because you don't have to shove everything into a single object, but you can have it potentially managed by the tool of your choice. So I'm going to go quickly to my last slides and bring this talk to a conclusion. So we have multiple constructs, which I didn't show you. Just know that they exist in the TriggerMesh integration language. One of them is event filtering based on the message data. So not only the message attributes like the type or the source, but you can filter on messages, actual data, using an expression language. You can also do some content-based routing. I showed you already. There is one novelty here is that you can also filter not only on attributes, but if you look at the last one, you can also route based on the condition which matches on the data. So data is not only for filtering, it's also for routing, which you don't have in Knative by default. You can do some fan out very easily by simply declaring an object of type PubSub. PubSub is in a category channel. Declare a list of subscriber, and all your events will be found out without you creating, brokers, triggers, subscriptions, and so on and so forth. You can do some message splitting. It can be relevant, for example, if you receive a large event containing a list of virtual machines, you want to split every virtual machine description into a single event for each. You can do that with message splitting. And message splitting, takes a path in the JSON or formatted data, telling on which item you have to split, and it will split that into multiple elements and send that to the target. We have data transformation. I showed you that. You can use, different languages like Python, in Node.js, and Ruby to perform transformation on your data. And last but not least, you can configure the delivery guarantees. So with data channels, so you can interpolate communication channels between each element so that every communication in your bridge is really asynchronous. And you can also configure the global delivery settings, which means if I set in my bridge description that I want the retry number to be 2 for each event, then it means that everything, including functions, including triggers, everything will be retried up to 2 times in case of failure. And I can also redirect the failures globally in the whole bridge to a single target. And if I was doing that in a bridge or using the YAML format, I would have to interpolate a single object between every of my components in the bridge, which would take a huge amount of time. So to conclude this segment, I would like to emphasize one thing: the actual language is not here what truly matters. I said I was using open source software for that, so the HCL language provided by HashiCorp, but that's not the only way to do that. You could also use the tooling of your choice to create your own language. And beyond the language, I wanted to demonstrate that it is possible to reap the benefits of infrastructure as code by simply bending well-known patterns into ways that fit the actual data flow. And this is really what's important here. And our language at TriggerMesh is just one implementation of the concept, but you could yourself design a grammar that better describes maybe your type of integration, and while still running that on a universal platform such as TriggerMesh, Kubernetes, Knative, generate the same kind of object and benefit from the same type of declarative APIs. So in conclusion, I want to ask a final question in the chat, as we've talked a lot about cross-service integration in this presentation. If you have some time, if you want to share, please respond to the poll, which is going to be posted to you now, and tell us how satisfied you are with your company's current approach to cross-service integration, if you have any. Right, so here are a few resources if you want to try out the platform and the language. Head to triggermesh.com/trial. You can request a free trial to access our platform. That was the one I was showing you during the presentation, and you can also try the TriggerMesh integration language for yourself if you already have a platform where Knative is deployed, or if you use the trial from TriggerMesh, you can use the language directly, play with it, look at our examples, and try to shape your own event-driven systems. Thank you for attending, and if you want to know more about TriggerMesh, feel free to access these resources which I share with you on this last slide. Thank you again.
Thank you, Antoine. That was awesome. All right, folks. And thank you so much to the folks responding to those polls. I'm going to leave that open for another couple seconds and see we can make sure we have time for everyone to log their responses. In the meantime here, I am going to announce the winners of our Amazon gift card drawing for today. And our first winner is Sarah P. Congratulations to you. Next, we have Richard B. Congratulations, Richard. Our next winner is Diane D. And our fourth winner today is Michael A. Congratulations to all our Amazon winners. Just as a reminder to the audience as a whole, the session has been recorded. So if you missed any or all of it, you can go back and watch it again. We'll be sending an email with instructions for how to access the webinar on demand. And for our Amazon gift card winners, we'll be sending you a separate email with instructions for claiming your gift card. So keep an eye on your inbox for those. And if you don't see them, please make sure and check your spam folder. All right, well, on behalf of myself and Antoine and TriggerMesh, we want to thank you for joining us today. It has been a pleasure, as always. We hope to see you again at another webinar very soon. That will do it for me. Sharon Florentine signing off.
Goodbye, everybody.